Hey guys, today we're going to work through some logarithm questions. We'll start out with some of the basics. This first section just simply says evaluate the logarithm. And what you have to understand is the word logarithm means exponent. So if you think about this first question, this 2 is the base. The log is what they're asking you, so I suggest you put a variable over here. So this is the log or exponent, and this 64 is the answer. So it's a really good idea to just simply rewrite this from logarithmic form, which looks confusing, to exponential form. So 2 is the base that has an exponent of x that will give you 64 as an answer. So you just have to solve this equation. Now, there's a couple ways to solve this equation. We're going to start by simply trying to get the bases the same. So think about it. If I said 7 to the what equals 7 to the third, this x would have to be a 3 in order for both sides to be equal. So anytime you have an equation with bases the same on both sides, the exponents must be the same. So we want these bases to be the same. So let's take this bigger number, 64, and think about a way we could rewrite it using a 2. If you think about it, 2 to the 6th is really 64. So if I rewrite 64 as 2 to the 6th, now the bases are the same. Therefore, the exponents are equal. So x is 6. Let's try another one. What about 87? Number 87 says log base 3 of 1 over 243. Once again, put your x there. Let's do the rewriting. 3 is the base, x is the exponent, 1 over 243 is the answer. Now this one's very challenging to rewrite because of the fraction. So what I'm going to do is I'm going to move this 243 to the numerator. If you do that, you could change the sign of the exponent. So 243 is really 243 to the first, but now it's 243 to the negative 1. And use your calculator and you think about how can I rewrite 243 using a 3. 3 raised to the 5th is 243. So 3 to the 5th to the negative 1. Whenever you have an exponent raised to an exponent, you can multiply those, and you'd have 3 to the negative 5th. So these 3's cancel. X is negative 5. Let's see. Let's try a different type of question. So in this section, we're going to expand the log expression. So there's some special rules that you can use for this expanding. If you have the log of a multiplication problem, let's say a times b, you can take this multiplication that you're taking the log of and take the log of the first part that you're multiplying plus the log of the second part. And you can go backwards as well, but right now we're expanding. What if you have a division, log of a divided by b? That changes to subtraction, log of a minus log of b. Another really important rule is if you have an exponent. What if you have a raised to the c? The c can be moved out in front as multiplication. C times the log of a. And then finally, if you have a radical, let's say it was a raised to the b and there's a c here. Well, first of all, any radical can be rewritten as a fractional exponent. this would be the log of a to the b over c, and then this exponent can move out in front. So let me show you how these rules work, starting with number 93. Number 93 says you have the log base 2 of 5x, or should I say 5 times x. We could use the first rule and say that this is the log base 2 of the 5 plus log base 2 of the x. And that's it. It's completely expanded. Sometimes it's helpful to break apart a very complicated problem. Likewise, let's look at 96. 96, you have log base 4 of 8x to the third. Now we have an exponent here, but first we still have a product. So we're going to break that apart. Log base 4 of 8 plus log base 4 of x cubed. This 3 can fly out in front according to this third rule here. So this is log base 4 of 8 plus 3 times log base 4 of x. Let's try a couple more. What about 99? 99 is a quotient. Log, actually it says natural log of 2x over y. Now this is a division, so we're going to break this up into the log of the numerator minus the log of the denominator. This is multiplication, so we could break that apart. Log of 2, plus log of x. And those should be in parentheses because that whole thing is the numerator of the y. And then finally, in this section, let's do number 103. What if you have log base 8 of the cube root of xy to the fourth? So overall, this is a radical, which we could take this xy to the fourth and rewrite it as 1/3, which can be moved out in front. So we have 1/3 log base 8 of xy to the fourth. Next, we have a product. So let's break that apart. This whole thing is going to be in parentheses, so it's a log base 8 of x plus the log base 8 of y to the fourth. And then finally, this exponent can fly out in front. 1/3 log base 8 of x plus 4 log base 8 of y. Now, in this final section, let's see if you can condense, which is the opposite of expand, log expressions. So, can you do the opposite of what we've just been doing? Well, let's see. Let's start with number 105. 105 says you have the log of 6 with a base of 7 plus the log of 11 with a base of 7. Now you can see that this is expanded and it has an addition sign. So that must mean if we combine or condense this, it would change back to multiplication. So the 6 times 11 can have just one log here. So really the final answer is log base 7 of 66. Log base 7, 66. Let's see. Let's do 108. 108 says you have the log, 3 log x minus 2 log y. Now, before we handle this subtraction, which seems likely it's going to change to division, this 3 has to go back up here as the x's exponent, and the 2 has to go back up as the y's exponent. We can't combine these or have these mingle together if the 3 and the 2 is not back up at its exponent spot. So this is x cubed minus log base 8 of y squared. Now that these two logs are all set, now we could do the subtraction rule. Log base 8 of x cubed over y squared. Let's see. Alright, I think we're good with that. Let me just show you one final thing. Remember at the very beginning of this lesson, we had to solve for x. And we had, as our very first example, 2 to the x equals 64. And if you recall, all we did was we got the 64 to be 2 to the 6, and then the x was the 6. But you probably can think of situations where these bases can't be the same. What we do is we can also simply take the log of both sides. The benefit of taking the log of both sides is that this exponent can move out in front, like we just witnessed in those previous questions. That produces an equation where you have x times the log of 2 equals the log of 64. Now you have to keep in mind that log of 2 is just a number. Log of 64 is just a number. So how do you undo multiplication by a number? You divide. Remember, log means exponent. So there's an implied 10 here if there's not a base. What is the exponent with a base of 10 that would give us a 2? It's just a number. So let's undo multiplication by division and see if we get the same answer. So the log of 64, divided by the log of 2. It should be, what was our answer before, 6? Yes, it should be 6. Let's see. So the log button's on the left side of your calculator near the 7. Log of 64, make sure you hit enter, divided by the log of 2. Bingo. X is 6. So give it a try and let me know if you have questions, and have a great day, guys.